This is a Friday Shoes production. Lesson 11-2 in our books on page 576. Target is I can display and interpret data in histogram. Data from a frequency table can be displayed as a histogram. A histogram is a type of bar graph used to display numerical data that have been organized into equal intervals. Again, it's a bar graph. The bars are touching, and we have equal intervals generated by a frequency table. Best way to learn is see it in action here. Let me do an example for you. Number one, choose intervals and make a frequency table of the data shown. Then construct a histogram to represent the data. Now you see they've given us some run times of movies, how many minutes each movie is, and they've given us, it looks like here, 20 movies. So first things first, we have to create a frequency table of that information. And we need to have some intervals generated, and the intervals have to be the same. So the least value in the data is 89, and the greatest is 219, as you can see. So they've chosen an interval size of 30 minutes, and that would yield a frequency table here at the right. What that says is each one of these intervals is 30 minutes long. Each one of them has exactly 30 minutes in it, and the intervals have to be the same. That's one thing you got to remember. So every one of these has 30 minutes in it. Then, of course, you just count how many movies fall into the 81 to 110 minute range, and that's 8. 8 of those, and then 8, 3, 0, and 1. These are going to be the heights of our bars when we actually draw our bars. All right, moving on. What do we do next? Well, we actually construct the histogram itself, and we follow these 3 steps. We draw and label a horizontal and vertical axis, and then we include a title. We show the intervals from the frequency table on the horizontal axis, and then for each time interval, draw a bar whose height is given by its frequency, which I stated earlier. So take a look. They've gotten our horizontal and vertical axis drawn. They've labeled. They actually have each interval down. So we have 81 to 110 all the way up to 201 to 230. And then the heights of the bars are as given here. We have 8, 8, 3, 0, and 1. And there is no space between the bars. Notice how the bars are connected there. And then because all the intervals are equal, all the bars have the same width. And then our study tip also says intervals with a frequency of 0 have a bar height of 0. This is referred to as a gap. So we have a gap in our data there, so we leave a little gap there. So there's your typical histogram. All right, let's do this one together. You can watch and listen and see how I put it together. It says the list at the right gives a set of test scores. Choose intervals, make a frequency table, and construct a histogram to represent the data. Well, you see the test scores, and in typical test score fashion, we usually go up by 10. So that's what I'm going to do here. And I see it starts in the 70s, ends with 100 here. I see one person got 100, and there's about 32. If I see, yeah, there's 32 pieces of data. So what do we do first? Let's create a frequency table. And again, I've chosen the intervals of 10. So I'm going from 71 to 80, 81 to 90, and then 91 to 100. Then we're going to tally those. So let's figure out how many are between 71 and 80 inclusive, meaning 71 and 80 are included in that. And we've got 5. And then you can see 81 to 90. Let me count that up for you. All right, we got 16. And then 91 to 100. Let me mark those off. Let's see here. Looks like I've got 11. All right, now that I've got that information, now I know how high my bars are going to be, and I can see what numbers I need to use for my frequency or my histogram itself on the frequency side or the horizontal side. So you can see I've done that. On the left side I have 5, 10, 15. I could have gone up to 20 there. I know we're going to get to 16. But then the test scores on the bottom here, we have 71 to 80, 81 to 90, and 91 to 100. Then I literally just draw bars with the same width, and they must be touching. Let's do that red one first. Let's go up to 5. And then the second one goes up to 16. And then the third one goes up to 11. Notice they're all connected. And that is a histogram. All right, let's analyze and interpret data if given a histogram. Here's number 2. It says baseball. How many Cincinnati Reds players were at bat at least 400 times in 2006? I forgot to ask on that. Well, at least 400 times. Well, here's the 400 to 499, and then at least means we can also include these people over here. So we need to know how far that's up, and then how far this one's up. This looks like it's about 5. This is 2, and that is correct. I believe that's what we're going to have for an answer. Well, 5 players were at bat in the 400s, and 2 players were at bat in the 500 times. Therefore, the 5 and the 2 added up is 7 players. So 7 players were at bat at least 400 times. All right, how about number 3? It says, what percent of the players were at bat 199 times or fewer? All right, let me start over again here. 199 times or fewer. Well, because there were, and you add all these up now, we've got 17 here, we've got 4 here, we've got 1 here, we've got 5 here, and we've got 2 here. So we've got 29 total. Total players with hits. And there were 17 plus 4, or 21. I'll do this in black here. These right here, total players that were at bat 199 times or fewer. And that's what they're looking for. How many, or what was the percent of the players that were at bat 199 times or fewer? So we've got 21 out of a total of 29. So these are the two numbers we need to find the percent. So 21 over 29, or 21 out of 29, is about 0.72 when we calculate that on our calculator. And that's 72%. So about 72% of the players were at bat 199 times or fewer. All right, how about our last one here? You can just walk through it with me, see if you can get the answers before I do. All right, B, it says, and this is the same graph from up at the top there. It says, what was the greatest number of times at bat of any one player? So any one player, what was the greatest number of times at bat? Well, I'm looking at this graph and I'm thinking, I can't figure out how many. I can see this. This is it right here, somewhere between 500 and 599. But do we know exactly what it was? Can we tell it what was the greatest number of times? No, but we know it's somewhere in the 500 to 599. So in this case, we would say this cannot be determined from the data. It only tells us that the greatest number of times at bat was between 500 and 599. We don't know exactly what the specific piece of data is just by looking at this histogram. We'd actually need to see the data itself. All right, how about C? Based on the data, how many times is a Cincinnati Reds player most likely to be at bat? Most likely to be at bat. Well, that one I can tell you, because which one seems to be the highest? It's this one right here. So I would say, based on this data, between 0 to 99 times is what you would expect the Cincinnati Red player to most likely be at bat. All right. For better understanding, of course, you can rewatch the video, or you can read the examples in our book, or you can try looking at some of the personal tutor videos on the online textbook. And as usual, this has been a Friday Shoes production.